Hi there, Year 13. Back again, general solutions. Again, looking at our sine. Grab out your formula sheets and we can begin. Oh gosh. Okay, let's have a look at our graph. This time, I have just drawn the graph of the y equals sine 2x. As you can remember, this is the 1 in the front there, so my amplitude is up to 1 and down to -1. And the 2 just tells me that I've got two sine graphs within a space of 2 pi. So one period for this case would just be pi, because I finish one full cycle in pi. So within that space of 0 to 2 pi, I will have 4 solutions where my graph cuts with the line y equals 0.5. So pretty much what I'm solving for here is sine 2x is equal to 0.5. Now this whole thing over here is my theta, and my answer that I get when I solve for the inverse of sine will be alpha. So 2x is going to equal, I know we did it the last time, but let's just look again. Shift sine, so inverse sine 0.5, and I'm going to get 0.524. Now, remember, I have got theta over there, and I have got, sorry, I need to change that color, alpha over there. So, if I was just going to solve normally for my first part, to try and find out what this value there is, sorry, it's not set properly on the screen, I would just go, x would be equal to, divide my answer by 2, and I get 0.2618. Okay, so this is the point 0.2618. This point here, however, instead of being pi minus like the last one was, if you look in there nicely, you can see that it's pi over 2. So this point over here would be pi over 2. I know that this distance is 0.2618. To be pi over 2 minus 0.2618. That distance over there would be pi plus 0.2618. And this distance over here would be 3 pi over 2 minus 0.2618. Because again, from there to there, each of those little spaces is 0.2618. So do that 6. Okay, hopefully all that makes sense so far. Make that a little bit smaller, and let's have a look at what I have. I have found that x equals 0.2618. It also equals pi over 2 minus 0.2618. It could also have been pi plus 0.2618, or it could have been 3 pi over 2 minus 0.2618. Remember, I could also have got all of those answers if I went into my graph mode and went sine 2x enter, 0.5, draw. I want my view window to go from 0 to, 6 point, 3 point, I was going to go to 7. Have a look at my draw. Okay, so there I have that graph, and if I go to GSolve and intersect, I get 2.618, push my little arrow button, and it'll tell me what the specific answers. I could have easily worked out what each of those were, and I will get all my answers. So we would use our calculator to find all of those points. Okay. However, in our internal assessment, we do need to write the general solution. So let's remember back. We know if theta is equal to n pi plus negative 1 to the n times alpha. Again, alpha is my 0.524, and theta is this whole 2x part. So I've got 2x equals n pi plus negative 1 to the n times 0.524. So I'll just move that over a bit so we've got a bit more space. Then I now can say, well, x is going to equal n pi plus negative 1 over n times 0.524, the whole side, because I had a 2 there, I'm going to divide both sides by 2, the whole side over 2. Now there's a plus over there. This is all times together, so I can simplify that as n pi over 2 plus negative 1n times 0.524. There, I'm done. That is my general solution, and that is how I could leave it if they only wrote write the general solution. I could then use my graph way to find those by putting it into my calculator as I did before. However, let us look at my general solution and just see how does everything link up. Okay. Let n equal 0. I have x then equals 0 times pi over 2 plus negative 1 to the 0 times, that's over 2. So that is going to be 0.2618. Sorry, I'm dividing the whole thing by 2. So that's going to equal 0 plus negative 1 to the 0 is just 1. 1 times 0.2618. So are you happy that when this whole thing is divided by 2, there's a plus sign there, so that can be written over 2, and that also has to be written over 2. So when 0.524 is divided by 2, we get 0.2618. And when n equals 1, we're going to have 1 times pi over 2 plus negative 1 squared times 0.2618. Now, negative 1 squared is going to be positive. So if you look, 1. Okay, sorry about that. Actually, recording at 10 o'clock at night isn't my best plan. Sorry, it was 1. So I put a 1 in there. Negative 1 to the 1 is going to get a negative. So I have pi over 2 minus 0.2618, which is the same as what I have over there. Again, if I say n equals 2, it's going to be 2 pi over 2 plus negative 1 to the power of 2 times 0.2618. Negative 1 squared is a positive. Those 2's are going to cancel, so I'm just going to leave with pi. That will be a plus 0.2618. I'm going to leave off there at the moment. Obviously, if you put a 3 in, it will be 3 pi over 2. Anything to the power of 3 would be a negative, and so on and so forth. I hope that just clears up how the general solution works. This is the important part, being able to get from that stage to that stage, remembering that anything that the sign has in its that it's signing, pretty much that whole angle does need to be kept until you've put this whole formula in, and then you divide across, and if it had a plus or a minus, that would all be brought into that point there as well. Again, thanks for listening. I hope that's cleared up some of the things that we've been looking at. See you in class.